today is I can find a z-score and use a standard normal table to find the probability of an observation happening. So yesterday when we dealt with the 68, 95, 99.7 rule, we had z-scores and we were finding the probability or the percent chance of something happening. The z-scores we were dealing with though were just 1, 2, and 3, or -1, -2, and -3. We're going to delve into a little deeper topic today. The first ones are just basic. Please write down the problem. What is the probability a z-score is less than 2.31? Let me give you a friendly reminder. A z-score is the exact standard deviation an observation is above or below the mean. If a distribution is normal, do you remember what z-score is considered extreme if it's above what z-score?
2.
2 or
3.
-2, right? 2 or -2. So yeah, 3 would be considered unusual or extreme. What's the probability a z-score is less than 2.31? The first thing I want from you, if it is not given, is I want a probability statement. Okay, so that's step 1. How do I write that probability statement?
0.9896.
Hold on. What's going on? Sorry guys. How do I write that probability statement? Will I write that? I don't know what's going on. Give me a second here. What? Does everyone have the problem written down? Okay, remember I can hear all of you. All right, so the first thing I said, we need to write a probability statement. And what is a probability statement? A probability statement is going to look something like this. The probability, so we say P, parentheses, of getting a Z, and in this case, because it's less than, whatever the Z-score is. So in this case, I want to know what is the probability, P, of getting a z-score less than 2.31. And now what we're going to do is we're going to go to our yellow sheet, our table, our z-chart. And I'm going to show you how to use this. What does 2.31 look like on the normal curve though? You're not required to draw this, but just so you know, here's my mean. 2.31, 1, 2, 3 is right here, approximately. I want to know what's the probability of ending up in that area. So I go to my chart. So I want you to take your yellow chart out now and let me teach you how to use it. Oh, thank you, Jack. It is less than. In AP Stats, it's almost always greater than, so that's just kind of in me here. So we're looking for the probability of less than. So what I'm going to do is I'm going to go to my chart. And if you'll notice on your chart, the first picture you see is a normal curve. You have the single peak, right? It's symmetric. And what I want you to notice is the Z is here. That's just an arbitrary point. But most importantly, it's shaded to the left. Which means all of these probabilities always work for a probability that Z is less than a number. That's really key, okay? That's really, really key about this chart. So you'll notice on one side you have positive numbers in this column. So look at this column right there where it says Z. And then on the other side, you have negative numbers right here. Do you notice that? Let me teach you how to read this chart. if I would highlight the column here, these are the first two digits of the z-score. So if I look at 2.31, I want to find the first two digits of my z-score. So am I going to find 2.3 on this one? Nope, I need to go to the positive side, and I want everyone to find the z-score with 2.3 only. So 2.3 is right here, right? So this column again is the first two digits of our z-score. Then what do you think this row is? Yeah, it's the last digit of your z-score. Oops. So 2.31, what I'm going to do, and I'm going to use the highlighter again. I'm going to go to 2.3, I'm going to go to this row. So I'm going to highlight it. You guys don't have to because you're going to use it over and over. 2.3 for the first two, and then 0.101 for the last digit. Do you see where that goes? So 2.3, 0.1, 0.9896. And that's the probability of getting a z-score less than 2.31. What did we say it was again?
9896.
I want you guys to practice one now on your own. Find the probability that z is less than negative 1.28. Okay, practice using that chart. Okay, so negative 1.2 is this row, right? And then 8 is this column. Did I get off, or is it 0.1003?
0.1003.
0.1003. So that's the probability of getting a z-score less than negative 1.28. Are we okay with the lessons?
Yeah.
Okay, we need to get cruising here. Next, what you'll get is you'll encounter a greater than. We're only going to do one of these. I only did it on your own because Eric stopped in and he needed some assistance quick. What's the probability a z-score is greater than 3.14? So again, I'm going to write down it as a probability statement. But this time I'm going to put the probability that z is greater than the number. The probability that z is greater than 3.14. Next, I'm going to go to my table. And I'm going to find 3.14. What's the probability that goes with it? So do that now. Everyone practice, please. Gunnar got 0.9992. Did anyone get anything different? Okay. 0.9992. Now I wrote it down here for a reason. Why did I do that?
So you could rewrite the problem.
Why do I do that, Jordan? He said I had to subtract from 1.
Because you have to get the opposite.
Exactly. So 3.14 on my chart is going to be like way over here. And I want the probability that it's greater than. But what did I say the chart always does? The chart always does less than. So this 0.992 represents the probability that z is less than 3.14. So step 3 is you need to do 1 minus the decimal you get from the table. So I take 1 minus 0.9992, and what do we get?
0.008.
And that's my probability right there.
Can't you just do it on the negative sign?
So it'd be like 1 minus the probability.
Yep, so you take 1 minus the decimal, or the probability. So the decimal you get from the chart, which is the probability of it being less than. All right, the last one we're going to do before we do a word problem, and we're almost done. You guys are doing a nice job. Am I going too fast at all?
No.
The last one is an in-between. sorry guys, what's the probability that the z-scores are between negative 2.51 and 0.26?
It's just an on your own.
No, I'm just giving you a second to write it down. So write down the question. I don't want to go too fast, so everyone get it down. And again, note your key words here. So we had a less than, we have a greater than, and now we have an in between. Bless you. Step one. Are we okay to start that, or do you need another second? Step one, write the probability statement again. Now, because it's in between, we have a z-score that's in between a small one and a bigger one, or a negative one and a positive one. It won't always be negative and positive. It will always have a smaller one, though, and a bigger one. So I take the probability of the small z-score is less than z, which is less than the bigger z-score. So I'm going to say, what's the probability of getting between negative 2.51, which is less than z, which is less than 0.26? Do we have any questions? Step two, you need to go to the table and find the probability or the decimal for both z-scores. Okay? Find the decimal or the probability. So it really is a probability as a decimal, right? Well, people are looking right now. Does anyone need help with the chart? I'm going to draw arrows right under these, and there's a reason I'm going to do that. It's just to stay organized. It doesn't matter how you do it and how you stay organized. I'm not going to grade you on this part. But this is where I'm going to write the probability for both z-scores. Did anyone get negative 2.51? 0.0060. Did anyone get anything different? Okay, 0.0060. And then I have 0.26. What did you guys get for that z-score?
0.6026.
0.60. Okay. And let's see if you guys can figure this part out. If I have a curve, I heard someone say it. What are we going to do? We're going to subtract the large one from the smaller one. And the reason that is 0.26 is right here. And that's this area. And then negative 2.51, the area 0.0060 is right there. So I need to take the green part and subtract the purple part to give me the in-between part. And that's what I want. So I take 0.6026 minus 0.0060. And what do I get, guys?
0.5966.
0.5966. And that's the probability. I want to do one word problem and we'll be done. You guys have been troopers because we went over. Today was kind of a long haul, so thank you so much. Here's the word problem. It's not very long, but please write down for me. I think if we do one, we'll be fine. I don't think I need to do the other one with you. So the mean score in an ECT is 21 and the standard deviation is 5. Find the probability of getting a 30 or higher on the ECT. So now what we're doing is we're taking what we've learned and we're applying it to actual real life here with a word problem. Okay, so you can see in my heading, the first thing we need to do is we need to find a z-score first. Okay, that's step 1. If you were gone on Friday, that was the lesson on Friday. The z-score formula. Please watch the notes if you need to, but the actual z-score formula is z is equal to my observation minus my mean divided by my standard deviation. So for this z-score, I'm going to take my observation. I got a 30 on the ACT. So z is equal to 30 minus the average, which is 21, divided by the standard deviation, which is 5. And what do we get for our z-score? 1.8. Is that correct? Did everyone get that? Perfect. Does anyone have questions on how we got 1.8? All right, step 2. Write a probability statement. What are we trying to figure out? We're trying to figure out the probability of getting a 30 or higher. Pay attention to keywords. So the probability that z is what compared to 1.8? Yeah, greater than. And we can just put 1 greater than. We don't have to put greater than or equal to. It doesn't matter. You won't get docked. If you look at different statistics books, some are just greater than, some are greater than or equal to. Doesn't matter. I'm going to keep it like this because this is what the high school book is like. Okay? So greater than 1.8. Now go to your chart. Find the probability for 1.18. So this is step 3.
1.18?
Or 1.8, I'm sorry. Now what do you notice about 1.8? It doesn't have a what? A second decimal place. So what is that second decimal place?
0.
0, very good. And what did we get for that probability, you guys?
0.9641.
0.9641. And now why did I say pay attention to keywords? We have to subtract from 1 because it's a greater than. The only time we can stop is when it's a less than. If it's a greater than, we have to subtract from 1. If it's a between, we have to do a big minus small. So I'm going to do 1 minus 0.9641. And what is that equal to?
0.
0.0359. Yeah, so Emma just noticed something. And I think Evan actually noticed it earlier too. Why can't we just go to the negative? Listen carefully. Everyone look at negative 1.8 right now. What do you guys notice?
It's the same.
It's the same. And why is that? What did I say about the normal distribution?
It's equal to 100.
It's equal to 100 and it's single peak. It's symmetric. I don't teach that because in the stats books we don't teach that. If you get that down and you have it, that's fine with me. I'm not going to be looking for your work for the 1 minus, but no stats book will teach you that. That's just something like a side note that teachers will talk with you about. Give me a thumbs up. I'm good. Because I feel like I rushed it a little bit to the side or down.
I'm golden.
All right, and your homework is not long. It's only 10 problems, so I do want you to do all of them, please. Thank you. Have a wonderful day, you guys.